Distortion factor meter. Distortion factor meter is used to measure the amount of distortion in the output of any equipment. So before we go for what a distortion factor meter is, let us just see what are the different types of distortions. So what are the basic types of distortions in electronic systems? The total harmonic distortion, and what are the different distortion analyzers. So distortion is nothing but the change in the original shape of the waveform. When you give an input, if the output is not the faithful reproduction of the input, then we say the signal is distorted. So it is characterized by the proportion of energy of a sinusoidal signal transferred to the harmonics. It is a measure of signal impurity. So it is a significant problem in electronic systems expressed as a ratio of undesired component to desired component signal. It is usually undesired. So if distortion occurs when the transfer function f is more complicated than yt equals a into x t minus k. So here you see when a square wave followed by a sine wave, a simple waveform, when it is passed through different circuits or different transfer functions, what is the distortion we observe in the waveforms. So here the first trace, which is in black, shows the output from a non-distorting or a transfer function, which is a straight line. So signal is made up of a square wave followed by a sine wave. Next, if you pass through a high pass filter, it will distort the shape of a square wave by reducing its low frequency components. That is, you can see the droop on the top of the pulses called the pulse distortion. So that is a green color waveform. Next one, if you send it through a low pass filter, it will round off the pulses by removing the high frequency components, the blue waveform, which is shown with the arrow mark. Next, if you send it through a circuit with slightly nonlinear transfer function, the waveform which is in the purple color, then it will compress the peaks of the sine wave. It causes small amounts of low order harmonics to be generated. Next, a hard clipping transfer function, that is the red type of waveform, the red waveform which is shown in the figure with the arrow mark, will generate high order harmonics. So parts of the transfer function are flat. The input signal has been lost in this region. So these are the different types of distortions when you pass the waveform through the different circuits. So there may be frequency distortion, phase distortion, or the amplitude distortion. These are the basic types of distortions. So here you can see the frequency distortion. So frequency distortion occurs when different frequencies are amplified by different amounts. So it is caused by combination of active device and the components. Different frequency components amplified by different amounts. Next is the phase distortion. The phase distortion is all the components of the input signal are not amplified with the same phase shift. So due to capacitive reactance or inductive reactance, we get this phase distortion. Next is the amplitude distortion. Amplitude distortion is the distortion occurring in the system or device when the output amplitude is not a linear function of the input amplitude under specified conditions. So two types of amplitude distortion may arise. It may be due to intermodulation distortion or it may be harmonic distortion. So what do you understand by this intermodulation distortion? When two sine waves of frequencies f1 and f2 are present at the input, resulting in the creation of several other frequency components, then we obtain the intermodulation distortion. So the third order distortion products 2f1 minus f2 and 2f2 minus f1, that is the multiples of the fundamental frequencies, will be close to the wanted signals. So those will be interfering with the signal which we require. So that is the intermodulation distortion. Next, also the frequencies may include f1 plus f2, f1 minus f2, 2f1 minus f2, 2f2 minus f1. Generally, m f1 plus or minus nf2 for integers m and n. So rapidly falls as m and n increase. So this is the intermodulation distortion. That is the different frequency components which are generated and they are present along with the signal which we require. So you can see here the red color waveform, that is a sine waveform, pure sine waveform is the fundamental component, and the next white color is the third harmonic, the blue color is the fifth harmonic, the purple color is the seventh harmonic. When these components or these frequency components are generated and when they mix up with the fundamental or the required component, then the resulted component, you can see the waveform yellow color, you see how much it is changed from the pure sine wave which we have, which we require. So that is a harmonic distortion. Okay. Now, harmonic of a wave is a component frequency of the signal that is an integer multiple of the fundamental frequency. This we have seen. So, if the frequency is f, the harmonics have frequency 2f, 3f, 4f, etc. Harmonics are all periodic at the signal frequency. What is the effect of third harmonic on harmonic fundamental signal? You please see here. So the fundamental pure sine wave we can see, the third harmonic can see, we can see the resultant waveform. So much distortion is present because of the third harmonic. So these are the waveform with the fundamental and the harmonics present. Harmonic distortion viewed on a spectrum analyzer. So if B1 be the RMS value of fundamental component, B2 B3 to Bn be the RMS value of its harmonics, then the percentage second harmonic component distortion D2 is given by B2 by B1. Third harmonic component is given by B3 by B1. That is the harmonic divided by the fundamental component. The nth harmonic is Bn by B1. So here the percentage distortion can be given as 100 into square root of B2 square plus B3 square plus B4 square up to Bn square divided by B1 square. So harmonics square of harmonics, sum of the square of the harmonics divided by the fundamental square. So that is given as 100 into square root of D2 square, D3 square, D4 square up to Dn square into 100. So this is the total harmonic distortion or the distortion.